the application of the stack which I have listed here. So these are the application of stack. We will see one by one what it is, and don't worry, I have also covered different sessions actually to write a program for each of these applications, and this is very much important interview perspective. So now let's see one by one what are the application of the stack. So first application is to reverse a string. So whenever you are given with a string actually, and you can use the stack in order to reverse that string. You can understand how. So this logic is very simple actually. You are given with the string, say the name, my name itself, that is Sonali. So if you keep pushing each character of this Sonali, if you are pushing S, you can see if you are pushing, you know that in stack first, so you are first pushing S, then you are pushing O, then you are pushing N, then you are pushing A, you are pushing L, and you are pushing I. That is Sonali. This is your top in case of the array. So whenever I am given with this string, I will push one by one in this stack, and I will simply then pop actually. When I pop, I'll get the last element, that is I, then I'll get L, then I'll get A, then I'll get N, I'll get O, and I'll get S. You can see how I got the string reversed. So you will write a program for that. I have dedicated different session for the same. This is the first application. The next application of the stack, that is this one, is to check whether balance parenthesis is present in your expression. That is, suppose you are given with this expression, that is say this 4. So this expression you are being provided with, and you have to check whether this expression is having the balance parenthesis. We know, you know what is parenthesis, this curly braces, this round bracket, round braces, closing, opening round braces, closing, and this curly. So you have to see whether this expression is having the balance parenthesis. That is, this is having this this opening curly braces is having its associated closing curly braces. This opening round bracket is having its associated close round bracket. So this we have to see that if what about you are given with this expression into this. So in this case, it will you have to check whether this expression is having balance parenthesis. You can understand it is not having balance parenthesis. This is not completed. Also, this is not completed. And this extra square closing square bracket is there. So that we have to check. So to check this actually, this is one of the application you can use, stack, to check this expression whether it is having balance. So this is having balance. It will mention you using the stack. This is a balance this is having balance parenthesis, and this is not having balance parenthesis. So don't worry about it. I have also covered different session for this problem itself. So we will see the program which is required in detail in C language. Each instructions I will be mentioning in that session, and this is very important interview perspective. So the next application where the stack is used is the function call. So you know that whenever one function is calling another function, which is calling another function, which is calling other function. So suppose your main function is calling func1, func1 is calling func2, till that much we'll go. Then in that case, the main function will complete its execution only when all these functions are executed. You can see first the main function is called, but still it has to wait till the function which it is calling to and the function that function is calling to, that completes its execution. So therefore the stack is used. So you can understand that is my main function is there. Yes, in main function, this is my main function, and I'm having func1, right? I'm calling this func1. Now this func1 again func2 is called, and this is final func2. So you can understand first the main function is called actually when the program is executed. Then this will not complete its execution. It is calling this function, control comes here, it's calling function 2, control comes here, function 2. So the till function 2 is completed actually. So first the function 2 will be completed. Even the function 2 is called very last, but still it will be executed very first. Then when the function 2 is executed, then this function 1 will be executed. then this function 1 is executed, then this main function will be executed. So you can see here, even if the main function is called first, but it will be executed very last. So this is where this stack can be used in this. Whenever your program is executed, in that case the program stack, or you can say the runtime stack, is created. When the function is called, actually in that case the activation record of that function which is called, so that activation record is what? It means it will have all the information related to that function call. Actually it will store in the structure, and that structure is called as an activation record. It is also called as stack frame, which is having all the information related to the function call. So it will have information like the variables, the parameters, then it will have also the pointer to the previous activation record, and it will have the address actually of the next instruction of the caller function which called it, so that when it is executed it will return to that next instruction which was pending to be executed. So also it will have, if the function is having some return, it will have that value. So all these informations which are related to the function call, it is stored in the activation record, which is also called as a stack frame actually. And when the function is called, what happens first? As I told you, when your program is executed, the program stack will be created. This is your stack, which is also called as a runtime stack. And in this stack, in that program, there is a function call. So activation record. So here you can see, here we have seen main function. So activation record of main function will be pushed onto the stack, which will have all the information related to that function call. As I told you, the variables, the parameters, the pointer to the earlier previous activation record, and the address of the next instruction of the caller function. All that details it will have. And when that function is completed with its execution, then this activation record will be popped from the stack. So this is where the stack is used very majorly in case of the function call. You can understand how important is the stack. So we don't know actually what happens in the background. So this is why I'm mentioning in the application itself. So when you write a program actually, and there are different various function call, main is calling func1 is calling func2. What is happening in background with the stack data structure? So this is what, there for the program execution, this program stack will be created, and for each function call, this activation record will be there. That is the information related to that function call that is stored in the structure, that will be pushed onto the stack one by one actually. And when it completes its execution, when that function is completed with its execution, it will be popped from the stack. This is how it will keep track in the stack. So this is all about the function call, the application of the stack, where it is used. Then the next application is infix to prefix, infix to postfix. This is very much important, and I have dedicated a different session for the same. We will see what is this infix, what is this postfix, what is this prefix, and why this conversion is required actually. So this is used for efficiency purpose, and how you can achieve using the stack, and it is a very commonly asked interview perspective. So you have to go through that session and visit that session, and I will be explaining you each instructions. I'll explain you the concept. I will explain you all the instructions written in the C language. We'll write a complete program for different sessions for them using the stack. And the next application, that is evaluation of the postfix. So all these terminologies I'll explain you, what is prefix, infix, postfix, and evaluation of postfix also you'll understand. I have dedicated different session for that also, and we will be covering the program there. So this is all detail about the stacks. You can understand at least what is stack, how important it is actually, and we have seen actually the real world example. I have given you example of the plates actually, and I have explained you the operations like the push and pop. First of all, these are the two operations, and what all things you have to keep into account, and these operations are performed on the top that we have seen. We have seen it is implemented, stack can be implemented statically, dynamically, that is stack using array, stack using linked list. What happens in using the array, what disadvantage is there if your overflow occurs, what things you have to keep into account, and you have to maintain this time complexity of big O of 1 in stack using linked list, how to achieve actually, and then these are the applications. So all these things I have explained. I hope you enjoyed the session. Also I have asked you to write some piece of code for the 2 problems which I have given, and I hope you please write it, because it is good practice point for you. We will be meeting in the next session actually, wherein we will be seeing stack using the array. We'll write a program for that, and then we will see stack using linked list and all the topics which I've explained you in the applications field that we will see one by one in the next session. So till then, bye bye, take care.